Understand the relationship between wave velocity, frequency, and wavelength. First of all, in order to understand the relationship between wave velocity, frequency, and wavelength, we must know the definition of it. The velocity of a wave is distance at given points when the wave travels in a particular time. Wave speed is measured in meters per second. The frequency of a wave is the number of cycles per second. Frequency is measured in hertz. The frequency is related to the time period through this equation. F equals 1 over t. As you can see here, is an example of a wave with high frequency.
Okay, that's good enough.
Whereas a wave with low frequency is shown like this. Finally, the wavelength of a wave is distance between a particular point on a wave and the same points on the next wave. Wavelength is measured in meters. Here's an example of a wave with short wavelength, while this is an example of a long wavelength. Wave velocity, frequency, and wavelength is all connected in a wave equation. V equals F lambda, or the newer equation that we just learned. Lambda equals H over mv. Apply the principle of superposition to the phenomenon of interference. Superposition is the combination of two or more waves. The principle of superposition indicates that the resultant displacement is equal to the sum of individual wave displacements. As you can see in this video, by combining multiple waves, Aaron and I create multiple superpositions that are equal to the sum of those individual wave displacements. Interference is the phenomenon in which two waves superpose to form a resultant wave of greater, lower, or the same amplitude. Interference effects can be observed with all types of waves. For example, light, radio, acoustic, surface water waves, or matter waves, or the example that is most relatable to us, beats, which is interference between the sound waves or nearly the same frequency, creating a loud, quiet, beating sound in the music we listen to. Recognize characteristics of EM waves and determine the type of EM wave based on its characteristics. First and foremost, the definition of EM waves or electromagnetic waves. Electromagnetic waves consist of oscillating electrical and magnetic fields acting perpendicular to each other. Different range of electromagnetic waves can be classified according to their characteristics and how they interact with the matter. The electromagnetic spectrum consists of range of wavelengths from the very long to the very short. Some of the examples could be radio and TV waves are the longest usable waves, having a wavelength of 1 mile or more. Microwaves are used in telecommunication as well as for cooking food. Infrared waves are barely visible. They're the deep red rays you get from a heat lamp. Visible light waves are the radiation you can see with your eyes. Their wavelengths are in the range of 1 over 1,000 centimeter. Ultraviolet rays are what give you sunburn and are used in black lights that make objects glow. X-rays go through the body and are used for medical purposes. Gamma rays are dangerous rays coming from nuclear reactors and atomic bombs. They have the shortest wavelength in the electromagnetic spectrum of about 1 out of 10 million centimeter. Secondly, electromagnetic waves share similar characteristic with every other waves, including amplitude, wavelength, velocity, frequency, which were all explained previously. The amplitude of EM waves is identified by intensity or brightness. Wavelength dictate which type of wave it is. The velocity of electromagnetic waves in a vacuum is 3 times 10 to the power of 8 kilometer per second, which is the same as speed of light, and frequency is just frequency.